So we are going to do inverse trig functions. You can do the trig functions forwards. You can do them backwards. What we're going to spend today doing only is learning what quadrants you're allowed to be in. Because when you go backwards, it's very, very picky. Remember how we went forwards? It could just be whatever quadrant it landed in. When you go backwards, it's not really like that. I'm going to show you why. So that's what today's lesson is learning where you're allowed to be, because that's like half about. So to do an inverse, you are going to switch x and y. You've learned that. We've done inverses. We're just doing them with trig functions now. So for trig functions, before the input was the angle, pi over whatever, and then the output was, the point on the unit circle. Or like if you think of it as opposite over adjacent, it's the, the sides of the triangle. Now that's going to be backwards. So this means that the input is now the ratio of the sides, which means your zeros and your ones and your, opposite over hypotenuse, or, we're using the y value or the x value or y over x or whatever it is. And the output is now the angle, which is the pi over whatever. So it's just reversed. So when we do these tables, we're going to do the y's first and then the x's because it's reversed. We did this with ln, like all the logarithmic stuff. Do you remember we plugged in y and got x? Like we did it backwards. It's the inverse of an exponential. So let's go ahead and put in for y our unit circle values. And actually, I'm going to go and write on the board a unit circle. So for sine, what part of the points are we using? The which one? Y values. All right, so look at your first point. What's your y value? 0. Good. And then up at the top of the circle, 1, back to 0, -1, 0. Usually people end up looking at me like, dumb as coal, like we know this already. We're just reversing it. Good. That's what we're doing. So whenever you go to graph this, do you see how now your pi's and negative pi's and everything is on the y-axis and like 0, 1, 2 is on the x-axis, like it's just reversed? All right, so we're going to start at 0, 0. That's our first point right here. So 0, 0. And then you have 1 pi over 2. It's going to be right there. And then 0 pi. So that's going to be right there. And then -1, 3 pi over 2. So -1, 3 pi over 2. And then 0, 2 pi. And so what you end up with, I have to turn the page to do this, is a sideways wave. Do you see this? And what I want you to continue doing is, fill in the rest of it. So keep the pattern going. And again, sorry, I have to turn the paper to do it. I always think it looks like the DNA strand. You know what I mean? Like the double helix from like science class. Whenever it's like, I mean, I know it's not, but just when it's upright like that, that's what I always see. That's what it always looks like to me. So that's what that's going to look like. You took the wave and turned it on its side. Exactly the same as we did with all the other inverse functions. You took the graph and turned it on its side. It's just we're doing the same thing with the trig function. That should bother you, though. You should go, hey, wait, hold on a second. What's the matter with that? Does not pass the vertical line test, which means it is not a function. Good. This is where the highlighter comes in. We're going to actually get rid of a whole big lot of that. You only get to keep a very, very, very tiny section. Oh, actually, first, before I go to the highlighter, you have to understand that the quadrants are based on the pi stuff, not the 1s and 2s, okay? Anything between 0 and pi over 2, between 0 pi and pi over 2 is quadrant 1. Do you see that? So quadrant 1 is this like little strip of space here. And then anything in between pi over 2 and pi, that's quadrant 2. So quadrant 2 is this little strip of space in between the two dotted lines. And then this is quadrant 3, and then this is 4. If you rotate backwards, like you're going, do you remember doing this? Like your clock hit and you go negative pi? Visually. Which quadrant do you go into first if you go backwards? 4. So when you go into the negatives, when you go backwards, this is 4, 3, 2, 1. So I'm sorry, I forgot to explain that. Now we're going to go to the highlighter. You always start with keeping what's in quadrant 1. So in quadrant 1 is this little section right here. So we're going to keep this part. I don't know if my highlighter is going to show up real well on the projector. Can you guys see that at all? You cannot at all. Does someone have a highlighter that's not yellow, or can I trade back for one of my ones that I gave you guys that was a different color? Can I trade you back for the orange one? Pretend it'll actually show up. All right, so you want that part. Ah, there we go. Now, can I go into quadrant 2? No. Do you see how if I keep that part, it'll fail the vertical line test? And here's the thing. If I can't get into quadrant 2, I also can't get into 3 or go any further. It's kind of like if you're driving down the road and a bridge is missing, you can't get to the other side. Do you understand what I'm saying? So like if I can't get into quadrant 2, how am I going to get over here? It doesn't connect, right? So you can't go any further that direction. Can I go backwards into quadrant 4? Yes. Can I go backwards further into quadrant 3? No, because then it will fail the vertical line test. So that's it. That's what you get to keep. Just that tiny little bit we highlighted. So let's go ahead and list out our domain and range. Domain is left to right. So that would be from where to where? -1 to 1. Do you remember how that was the range for the sine wave when we did it before? Now it's the domain. Now, whenever you do the range, that's downwards to upwards. So that's from where to where? Well, we're going with pi. So it's going to have to be something with a pi in it. From down here to up here. -pi/2, good, to +pi/2. Are you guys seeing that? And just for good measure, I'm going to bring this up as well. Is this an even function or an odd function? We did these before, but I'm just seeing if anyone... This one's odd. So sine inverse is in quadrants 1 and 4. Can anyone give me, and you still need to know how to fill in a unit circle, some pi over whatevers that are in quadrant 1? What's in quadrant 1? Starts with 0 pi, and then what are some of the other ones? Pi/6, good. What else? Pi/3 is in there? Pi/4, and then at the top, pi/2. If you go backwards into quadrant 4, you would have all of those except negative. You'd have -pi/6, -pi/4, -pi/3, -pi/2. That's all that you're getting out of this today, is what angles are available to you. Cool? Guess we'll see when you go to do the check your understanding. All right, we're going to do the exact same thing here. You're going to plug in your pi values for y, and then all your zeros and ones and -1s are going to be the x values. We're just reversing it. So when you go around your circle, how do you get cosine? X, good. What's the first x number? 1, good. And then up at the top of the circle, the x is 0. And then -1, 0, 1. Cool. I want you to go ahead and plot them. It's going to look remarkably like this one, except not start in the same spot. All right, you're going to start at 1, 0, which is right here. And then I'm going to stop narrating because I know that that's annoying. Just take these points and put them on your graph. And then just keep the pattern going so that you can fill in the whole thing. And then once you get it drawn, you're gonna pull out your highlighter and we're gonna highlight the part we get to keep, which is precious little. You don't get to keep very much at all. So you always start with quadrant 1, that's this part. And then without breaking the vertical line test, what other quadrant can we get into? Yeah, you can keep going into quadrant 2. Can you get any further into quadrant 3? No, because it bends back on itself. And can you go backwards into quadrant 4? No. So that tiny little part that we highlighted, that's all you get to keep. So let's list out our domain and range. Domain is left to right. So what is that going to be? Yeah, -1 to 1. And your range downwards to upwards, just the highlighted part, 0 pi to 1 pi. So can you give me some angles that are in there on your unit circle? Pi over 6, pi over 4, or you're giving them to me in order. Pi over 3, pi over 2, it's like a clock hand going around. But then we get into the second quadrant. Do you remember some of those? You need to be able to fill out a unit circle. That's in quadrant 2. 2 pi over 3 is in there. 3 pi over 4 is in there. 5 pi over 6. There, you got them all. Good. And then pi. Okay. Is this one even or odd? Even. Good. And so it is in quadrants 1 and 2. There's 6 of these, so we'll do one more. 3 will be halfway. And we'll do our halfway break. All right, so again, you're going to fill in your angles for y, and then from the circle, you get your x's. Inverse just means it's reversed. X and y got switched. So how do you get cosecant from the unit circle? You flip the y values. So you're going to end up with some undefineds here. All right, so your first y value is 0 if you flip that undefined. Then you're at the top of the circle. What's your y value? 1. If you flip that, 1. And then could you keep it going? It's just a pattern. The next one, undefined, and then -1, undefined. Now, for cosecant, they were vertical asymptotes. For cosecant inverse, they're going to be horizontal asymptotes. So it's just turned on its side. So at 0 pi, you have the asymptote. That one's hard to see because it's on the axis, but it's going to go like this. Oops. And then you get a point 1 pi over 2. So that's right here. And then another asymptote. And then you get -1 3 pi over 2. And then another asymptote. And so you're going to get those U shapes, but they're going to be on their sides. And again, just fill it in for the whole rest of the way. All right, and then you're going to grab your highlighter. We're going to always keep what's in quadrant 1. So that would be this portion. And then can you get into quadrant 2? No, which means you can't go any further that way. Look at if you go into quadrant 1, but then quadrant 2 is off limits, you're stuck. You can't go, like, you can't get from there to there. Again, it's like you're driving down the road and a bridge is missing. Well, you can't get a quadrant 2 is missing, you can't get to 3, right? So you can't go any further that way. Can we do quadrant 4 though? Yeah, this part's okay. Can you go further backwards into quadrant 3? No, because it'll fail the vertical line test. You can't go very far because it won't be a function anymore. All right, so we're going to do the same things, domain and range. Domain, you're going to go left to right. So what do you think? Good, that portion's negative infinity to -1 right here. And then union. Oh my gosh, guys, that used to be the range. Now it's the domain. Crazy. All right, and then your range. So we're going to go downwards to upwards. So where does it start here? Because this is actually going to be a little weird looking. It starts at -π/2, good. And so watch me point to this. It goes from -π/2 all the way to +π/2, but you have to skip over what? What do you have to leave out? Yeah, which is at 0 pi. All right, so it's going to be to 0 pi. You're going to leave that out, and then it goes all the way up to π/2. So some values that would be in there: -π/2, -π/3, -π/4, -π/6, not 0 pi, and then all the positive ones in the first quadrant. All right, so that one is in quadrants 1 and 4. And if sine was odd, that means cosecant is also odd. The reciprocal ones go together. So if sine was odd, cosecant is also odd. So how would we get our secant values from our unit circle? When you go around the circle, how are you going to get these? You're going to flip the x values. All right, so go ahead and plug in your, I'm sorry, I'm going to make it so you can see it. Plug in your 0, π/2 pi, 3 π/2, 2 pi, and we're going to go around and flip all of the x values. It's going to look a lot like the one we just did, except start in a different place. So what is your first x value? The beginning. 1. If you flip 1, it is 1. 1/1 is 1. Without even looking at the circle, though, what's the next one going to be? Like, just use the pattern. Yeah, undefined, and then -1, and then fine, and then +1. You know, like, if you listened to me teach it to you, you're going to know it. All right, so go ahead and plot those on there. You're going to start with 1, 0, which is right there. And then asymptote. And then -1. And I'm going to stop narrating because I know that's annoying. But just continue it a little bit in each direction. All right, and so when you go to highlight, you always start with quadrant 1. And then which other quadrant can you get into without causing it to not be a function anymore? Quadrant 2. If you go anywhere else, it's going to fail your vertical line test. So we're going to do the same thing we did for all the other ones, domain and range. Domain is going to be the same as for inverse cosecant. You're going to have -infinity to -1, and then union 1 to infinity, which again, that was the range for secant and cosecant. So now it's the domain for the inverse functions. All right, and then range is a little tougher for this. Where does it start? Let's go with that. So we're going to go downwards to upwards. So what value are we starting at? 0 pi. And then it goes all the way up to pi but you have to skip over where the asymptote is. So we're going to skip over what? Yeah, pi over 2. You have to leave out where the asymptote is. So we're going to leave out pi over 2. It's 0 to pi, but you have to skip over pi over 2. And then even or odd, it matches the reciprocal one. So even. So cosine was even. So secant is even. And just to recap, it's in quadrants 1 and 2. Cool. All right, last two. Now for these ones, you only go halfway around the circle. Remember this? It wasn't that long ago, so I think so. So when you go to fill in your y values, it's going to be 0, pi, and then what? Because these ones are different. It's only halfway around. What's the next one going to be? Pi over 4, good. And then pi over 2, and then 3 pi over 4, and then what? Just 1 pi. Good. Halfway around. So how do you get your tangent values from your circle? So y over x. Good. So look at the first one. That would be 0 over 1. 0 over 1. 0. Good. Perfect. And then the next one is that square root of 2 over 2 stuff. Anything over itself, 1. Up at the top, you have 1 over 0, undefined, and then it's going to be -1, and then back to 0. It's going to be a sideways wiggly thing. You're going to start at 0, 0. Now, watch me plot this. It's 1 pi over 4, which is going to be right there. Do you see how it's in between? Because pi over 4 is halfway in between 0 and pi over 2. And then at pi over 2 is the asymptote. And then -1, 0, 1, and then another asymptote. And again, you just want to fill it in a little bit each way. Try to draw mine as fast as I can so I can get my hand out of the way so you can see it. It should look like that. All right, and then when we go to highlight, again, you always start with quadrant 1. And then this one, it kind of feels like there's 2 different choices, which there sort of is. Could you get into quadrant 2 without breaking the vertical line test? You could get into quadrant 2 or quadrant 4. Want to give it a guess? Because one of them is right and one of them is wrong, actually. It's 4 because it's odd. The other odd ones were quadrants 1 and 4. The even ones are 1 and 2. So that's why it's 4. And we're going to write out the same things that we did for all the others. So domain range, I just said it was odd. You can go ahead and say odd. And this one is in 1 and 4. So again, to recap, the odd ones are in 1 and 4. The even ones are in 1 and 2. I told you that was going to come up. Remember like me saying like, hey, that's going to happen. Today's that day. So what do you think for domain, left to right? Yep, everything. Oh my gosh, that was the range before. Now it's the domain. Cool. And then your range. You're going downwards to upwards, so it's starting where? Where are we starting? -pi over 2. but bracket or parenthesis. Good. Why is it a parentheses? Yep, it doesn't touch. There's an asymptote there, so negative pi over 2 up to positive pi over 2, but again, a parenthesis. So on your check your understanding, when you're selecting which pi over whatevers go in that one, you can't include those. But you will get negative pi over 3, negative pi over 4, negative pi over 6, 0, pi, like I'm telling you the answers, but like that's the takeaway for today is where do they end up, right? So you have to know this in order to do the next thing. And why is she harping on about it? You have to be able to do this in order to do what we're going to do next time. All right, and then the last one, do the same thing. Fill it in with your values, except only halfway around, so count by fourths. And how do you get cotangent from your unit circle? Good job. X over Y. So look at your first one. That's 1 over 0 is undefined. And then the next one is that square root of 2 over 2 stuff. Anything over itself, 1. And then basically just keep the pattern going. It goes 1, 0, -1, undefined. Hang in there. It's the last one. All right, so go ahead and take that information and plot it on here. Your wiggles should be going the other direction. So you start with the asymptote and then you get 1 pi over 4. Again, it's kind of floating in space there. 0 pi over 2, -1, 3 pi over 4, and then another asymptote. And then this one's going to seem really weird when we highlight. But if tangent inverse is odd, cotangent inverse is also odd. And so which quadrants is it going to be in? The odd ones are where? 1 and 4. So there's 1 and then here's 4. So it gets broken, sort of. Well, not sort of, it does. So it's odd. It's in quadrants 1 and 4. Where are the even ones? If the odd is in 1 and 4, where are the even ones? 1 and 2. Okay, that's the takeaway for today. All right. And then we're going to list out our domain and range. Now, I know it got broken, but if you do domain left to right, do you see how the one piece picks up where the other one leaves off? So if you sweep left to right, what's your domain? Yeah, it's still all reals because the one part picks up where the other one left off. Do you remember that happened with the piecewise function? So I guess that kind of is a piecewise function. Oh, what type of discontinuity is this? Removable or non-removable? Oh, good. Non-removable. Because you didn't just remove a point. It's like actually broken. All right. And then your range. Sweep downwards to upwards. So where is this starting at down here? Am I including the negative pi over 2 or not? What do you think? Yes, there's actually a point there, right? So bracket negative pi over 2. Yeah, we have to leave out 0 because there's an asymptote. So leave out 0 pi. Hop over that one, and then it goes all the way up to pi over 2 with a bracket.